Fiber channel over Ethernet is certainly one of the most exciting technologies to hit the data center in a long time. This, of course, gives us the realization of a converged, a unified data center, and it's a big part of the reason why Cisco Systems uses the marketing term the unified fabric. In this particular nugget, we're going to take a look at troubleshooting issues for fiber channel over Ethernet. In particular, we're going to focus on fiber channel over Ethernet initialization protocol, something that is often kind of overlooked and is a key troubleshooting element. So, fiber channel over Ethernet initialization protocol, or FIP, is our control protocol that's responsible for establishing and maintaining the virtual links that we have between our fiber channel over Ethernet devices. Fiber channel over Ethernet and therefore FIP are supported on things like the Nexus 5000, the 5500, the 7000 F series modules. And the fiber channel over Ethernet initialization protocol is going to handle three main tasks for us. It handles device discovery, it handles initialization, as its name implies, and also link maintenance tasks. Now, it's important to understand there are two modes. There's what we call FIP mode and pre-FIP mode. FIP mode is the Converged Enhanced Ethernet Data Center Bridging Exchange Protocol. It's a T11 compliant particular protocol, and we have it in our second generation converged network adapters. As you might guess, first generation CNAs are going to feature the pre-FIP protocol. So you could run into a real issue here. For instance, on the 5500 series platform, there is no support for this pre-FIP behavior. What command you would utilize in order to verify your particular fiber channel over Ethernet initialization protocol support would be one of the largest commands that we have in the course: show system internal DCBX info interface, and then specify your particular interface. There is a field in the output that is returned that says DCX protocol. You are dealing with a FIP device if it's reported as CEE. You are dealing with a pre-FIP device if it reports CIN. So this is one of the first important, obviously, considerations when we're troubleshooting fiber channel over Ethernet in our Cisco environment. Now let's focus in a little bit more on this virtual link establishment that our FIP is going to perform for us. And first we look at a single hop. So we have an E node, and then we have a fiber channel forwarder that we are dealing with in this relationship. FIP is looking to establish our virtual fiber channel link between our virtual node ports and the virtual fabric ports. For multi-hop, the links are going to be established between virtual expansion ports. But FIP between VN ports and VF ports performs the device discovery, the initialization, and the link maintenance, and uses several protocols in order to do this. First is FIP VLAN discovery. Discovery of the fiber channel over Ethernet VLAN is used by all the other FIP protocols as well as by the fiber channel over Ethernet encapsulation for the fiber channel payloads on the established virtual link. Then there's the discovery protocol. A discovery solicitation message is sent out when a fiber channel over Ethernet device is connected to the fabric. A fiber channel forwarder or switch responds to this message with a solicited advertisement that provides a fiber channel forwarding MAC address for subsequent logins. Then we have our virtual link instantiation. What a great word. FIP defines the encapsulation of fabric login, fabric discovery, logout, and exchange link parameter frames along with the corresponding reply frames. Fiber channel over Ethernet devices use these messages to perform the floggy process. Then finally, we have the virtual link maintenance. Periodically, FIP is going to send out maintenance messages between the switch and the converged network adapter. These messages are used to ensure that the connection is still valid. Fiber channel over Ethernet has 3 Ethernet group addresses reserved for multicast operations. There's an all fiber channel over Ethernet max, there's an all eNode max group, and there is an all fiber channel forwarder max group. Now, as I said, multi-hop fiber channel over Ethernet supported across VE ports, as you can see here, like between two 5500s. These could be 7000 series, they could be MDS series switches. A VE port is a port that emulates an E port over a non-fiber channel link. This port is supported over point-to-point links between our fiber channel forwarders. These links can be Ethernet interfaces or members of an Ethernet port channel interface. For each fiber channel forwarder connected Ethernet interface, you need to create and bind a virtual fiber channel interface to the Ethernet interface. Remember, there are some guidelines here. Auto mode on the virtual fiber channel interface is not supported. VE port trunking is supported over the fiber channel over Ethernet enabled VLANs. VE port interface binding to MAC address is not supported. And finally, a VE port is enabled for trunk mode by default. Spanning tree protocols disabled on the fiber channel over Ethernet VLANs on any interface to which a virtual fiber channel is bound, including the interfaces to which the VE ports are bound. The fiber channel over Ethernet initialization protocol virtual link establishment process for multi-hop fiber channel over Ethernet is similar to the single hop I described a moment ago. After fiber channel forwarder discovery, there is a process of ELP between two VE ports. Fiber channel commands follow as part of our fiber channel over Ethernet protocol. So maybe your issue is your virtual fiber channel is down because FIP isn't properly supported. Yeah, if your connected host doesn't support FIP, the first step, obviously, of VLAN discovery is going to fail. You can use the following show command, again, a mouthful, but this show command can help you verify the FIP support. Specifically, the output of this command will list a field that straightforwardly says FIP capable. And there'll be a question mark and then a colon. So we look for this FIP capable field and we desperately want to see a true here for the particular device. Remember, it may be that we have to update firmware or update drivers on a converged network adapter in order to ensure we have the FIP support that we need. Now, if the first step of the VLAN discovery succeeds, then we know our host sends FIP solicitations. The switch should respond with FIP advertisements in detail. If this step is having an issue, then obviously the virtual fiber channel is not going to come up. Maybe you don't have active fabric provided MAC addresses. Maybe the fabric's unavailable for the floggy process. Maybe the MAC address descriptor is incorrect. Again, this command here can really help. In the output, we can see the particular events that have been triggered. So let's make sure that the vSAN is properly active, that memberships are correct, that the fabric is available. And if we're in N-port virtualization mode, we need to confirm that an active proxy N-port is indeed available. Another thing that you can do is you can run this command, eth analyzer local interface inbound high. Now, what's great about this built-in analyzer of traffic on the Nexus is that we can literally check for FIP frames. Remember, the FIP frames are going to be tagged 0x8914. So we can literally check for FIP frames in the output. If these frames aren't showing up, they might be being dropped in hardware. So we can check for packet drops at that point. On the 7000 series, we can attach the module number and then use the command show hardware internal statistics packet flow dropped in order to check for such drops. Another thing for us to check is the native VLAN ID. So here's our fiber channel forwarder. Here is a host. We've got our port right here. We have to watch out and ensure that a bound interface native VLAN ID is a non-fiber channel over Ethernet VLAN. If not, if the native VLAN matches the FCoE VLAN, then the VLAN response that is going to be sent out is untagged. But the FIP adapters are going to expect tagged frames. Therefore, the native VLAN on the trunk interface should be a non-fiber channel over Ethernet VLAN. Obviously, you can use show interface Ethernet port trunk in order to check the configuration on the bound Ethernet trunk interface. Something else we should check for here is STP forwarding. This bound interface should be in a spanning tree protocol forwarding state for both the native VLAN and the member fiber channel over Ethernet VLAN that's mapped to the active vSAN. If no spanning tree protocol active ports are on the VLAN, then the switch will drop all FIP packets that are received on the VLAN over the bound interface. So again, show interface Ethernet port trunk, show span VLAN for the fiber channel over Ethernet member VLAN. These commands can help us ensure that our spanning tree protocol is indeed in a forwarding state on that bound interface. Well, the good news is at this point we have covered the major issues that you should be aware of when it comes to fiber channel over Ethernet. The bad news is the certification exam from Cisco on this subject can get real kind of corner case, can get real specific. The great news is those questions would come from this particular document. So I've included this in the Nugget Lab files for you. Pay attention to specific platform issues like on this Nexus 5548. We can see that one of the issues is this particular QoS configuration that you would need for fiber channel over Ethernet is not input by default. You have to go in and manually input this configuration. So check out these corner case situations, read this entire document, not that long, 18 pages total, and it'll be a nice review of a lot of the information that we spoke of, and you'll see some other great details on fiber channel over Ethernet troubleshooting as well. So in this nugget, we obviously took a look at the ins and outs of troubleshooting fiber channel over Ethernet. I sure hope this nugget was informative for you, and I'd like to thank you for viewing.